Another thing we need to be able to do in addition to graph an ellipse is be able to write them in standard form. So we're going to do that by completing the square. And this is very similar to what we did when we were dealing with circles. Okay? So the first thing I notice is that I've got x squared and y squared, but I also have x and y terms, and it says equals 0. And I know an ellipse eventually needs to say equals 1. So any constant term, I'm going to start by moving over to the other side. So I'm going to add the 78 over. I'm also going to rearrange these so I have the x's together and the y's together, okay? So I'm going to make this 4x squared plus 24x, and I know I'm going to have to do something there momentarily, okay? And then I've got the 3y squared minus the 12y, and I'm going to move this negative 78 over to get a positive 78 instead, okay? So now, with circles, it was easier because there was always a 1 in front of the x squared, but now I've got the 4 and the 3, so I'm going to need to factor those out. So from these two, I'm going to factor out a 4, and that gives me x squared plus 6x, and this is where I'm going to insert my unknown value, okay? So this is where I'm going to fill something in so that this factors into a perfect square trinomial, okay? And on this one, I'm going to factor out the 3, and that's going to leave me with y squared minus 4y plus some unknown number, okay? So that becomes a perfect square trinomial. And now to balance that off, I'm going to have 78 plus 2 unknown numbers, okay? There's going to be 2 unknown numbers to add, and I'm out of space, so I'm going to stack them instead of put them next to each other. All right, so let's go ahead and try to figure out, well, what would have to go right here? And remember, when we're completing the square, we take this middle b value, okay? So the 6, we cut it in half, and we square it, and that's what goes right here. So this is really 3 squared, which is 9, okay? Now when I put that on the other side, that 9 is getting multiplied by this 4, so this first blank is going to be 4 times 9, or 36, okay? So it's not just a 9 going in the blank here, I've got to multiply by the coefficient that was out in front of the parentheses, okay? So that's the first one. Now we need to deal with the y's, okay? So here, we have to take the negative 4 divided by 2, square that, so that comes out to negative 2 squared, which is positive 4. And again, I'm putting a positive 4 in this blank, but that 4 is getting multiplied by this 3 out in front, so this second blank is going to be 3 times 4. Okay? So now let's see what the factors are going to look like. Out in front of the x, I have 4, and then parentheses squared is going to come out of this. To get to x squared, I need an x. To get to the 9, I need the 3, and because it's a positive in the middle, I need the plus sign. Okay? So again, same as we did when we were dealing with circles and when we were dealing with parabolas. Okay? Then I've got the plus 3, and now I'm going to have parentheses squared. To get to the y, to get to the y squared, rather, I need a y. Because there's subtraction in the middle, I need a minus. And to get to the 4, I need the square root of 4, which is 2. Okay? Now on the right-hand side, I have 78 plus 36 plus 12. And that comes out to 126. So we're not going to actually keep that there. We're going to write equals 126. So now I have my x squared expression, my y squared expression equals 126. But we know that to get to an ellipse, it has to say equals 1. So the only way I can do that is if I take everything and divide it by 126. Divide this by 126 and divide this by 126. Okay? 4 over 126 isn't the prettiest thing in the world, but we have to have a 1 out in front. So we're going to have a decimal involved, and that's okay. So 4 and 126, that's going to reduce down to 1 and 31.5. Okay, so decimal's totally fine here, plus. And then in the numerator, I've got y minus 2. 3 and 126, that becomes 42, and this is equal to 1. So that means that the center of this ellipse would be at -3, +2, and then I'd have some pretty funky A, B, and C values for this particular one. So this is not something you would ever be asked to graph, just something to be able to translate it from non-standard form into standard form.